Good evening, dear students. Today's theme is loops. Lazarus provides you with ready-made control structures for looping, so you can avoid such messy code. The control structure contains both the branching statement and the condition in one construct. In this chapter, you are introduced to the following constructs: the for loop, the while loop, the repeat loop. Each of the three loops has different features that suit different applications. The for loop. The for loop construct is a counted loop used to repeat a statement or block of statements a specified number of times. It includes the initialization of the counter, the condition, and the increment. Look at this example. Program for loop var counter. Counter is variable and the type of variable integer. Begin for counter is equal to 1 to 5 2. Right line, say again, right line, press enter to continue, read line and end. This program gives the same results as the previous programs does, but is simpler and better organized. The for loop does the same work done in the previous program. It assigns the control variables the initial value of 1. Then executes the statement, increments the control variable by 1, and repeats the process until the value of counter reaches the final value of 5. The general form of the for construct is as follows. For control variable is assigned to expression 1 to expression 2 do statement, where control variable is the loop counter. Expression 1 is the initial value and expression 2 is the final value. The control variable expression 1 and the expression 2 can be of any type except real. All three must be of the same type TIP. Remember that the for construct is one statement ending with a semicolon. If by mistake you add another semicolon, as in the following loop, for counter is assigned to 1 to 1002. Right line, say again. Don't be surprised if the loop is executed only once, regardless of the final value of the counter. The semicolon after the do keyword ends the loops at this point. The value of the control variable may not be modified inside the loop. Look at this assignment statement inside the loop. For k assigned to 1 to 10 do. K is assigned to 2. Even if the compiler accepts this statement, it will repeal the effect of the loop counter as it sets it to the value 2 all the time. The same rule applies for the initial value and the final value of the control variable. As usual, you can include as many statements as you want inside the loop by using the begin and blocks. Example, powers of 2. The number 2 and its powers are very important numbers. In the computer field, some of the numbers such as 124 bytes equivalent to 1 kilobytes and 65,536 bytes are commonly used. In the following program, a for loop is used to display the powers of 2 using the same logic that was used to calculate the power in example 4. The program output gives the power and the number 2 raised to this power. The initial and final values of the counter are supplied by the user during the execution. Thus you can determine the range of numbers you would like to examine. This is example 4. So Example, the average. The following program demonstrates data entry using a loop. It receives a series of numbers from the keyboard and calculates the sum and the average of the numbers. At the beginning of the program, you are asked to enter the number of the elements n, which is used as a final value of the counter. Inside the loop, the sum is accumulated in the variable sum using the statement. Sum is assigned to sum plus number. When the loop exceeds, the average is calculated from the sum and the number of elements using the statement. Average is assigned to sum divided by n. Here is the program, and this program about the average of numbers, how we can solve the average of numbers. Stepping up and stepping down. In the previous example, the for loop counter was always incremented. This means that the final value of the counter must be greater than the initial value, or else the loop will never execute. You can decrement the counter using an alternative form of the for loop by replacing the keyword to with the keyword down to, as in the following form. For control variable is assigned to expression 1 down to expression 2 to statement. In the previous example, the for loop counter was always incremented. It's repeated this. So it's example about factorial, how we can solve factorial numbers. So vocabulary: opposite, против, datum, элемент данных, distinguished, выделенный, отличный, discrete, дискретный, implementations, выполнение, underage, несовершеннолетний, obligation, обязательство, distinct, особый, отличный, infinite number, бесконечное число, effort, попытка, усилие работ, объем работ, explicit, ясный, подробный, assures, обеспечить, гарантировать. Subrange, поддиапазон, ordinal type, порядковый тип, permitted, позволять, разрешать, restrictions, ограничения. To set a switch, устанавливать ключ. Subrange, поддиапазон, ordinal type, порядковый тип, permitted, позволять, разрешать. Actually, действительно, recognized, признавать, узнавать. Involved, возводить в степень, вовлекать, запутывать. Thank you for attention.